Greetings everyone and welcome to Revolution of Reality. In my previous episode, I spoke of the revolution of reality that many physicists are investigating, which is the theory of a holographic universe. My intention in the videos ahead is to show why the physics of a holographic universe not only solves many mysteries in physics, it also explains the physics of the paranormal. However, the idea that the universe could be some type of hologram seems absurd to most of us, since holograms are completely insubstantial. But that's only because our school education has completely misled us about what we are made of, in the name of simplification. Essentially, we are as etheric as ghosts according to mainstream physics, which is why physicists have no problem proposing that the universe could be a type of hologram. I think I can safely say that nobody understands quantum mechanics, said Richard Feynman, a leading expert in this theory that describes particles and atoms. The bottom line, as discussed in my previous two videos, is that everything is made of particles, yet particles are a mystery, and reality is a mystery. Therefore, you and I are fundamentally a mystery. We could be taught about this mystery at school. However, what we are taught instead is an example of a lie to children, as this entry in Wikipedia points out. In other words, it's a simplified but false explanation of a complex subject as a teaching method for children and lay people. The justification for teaching wrong ideas in physics is as follows. The current model of the atom, the quantum model, is the one that should be taught in school. However, the quantum model is quite complex, so the decision was made to initially teach the planetary model before moving on to the quantum model, even though the planetary model was discarded in the 1920s because it was flawed. The problem is that the quantum model is typically only taught at university level, and most people will never get exposed to it. So, even though the planetary model is hopelessly outdated and wrong, the vast majority of people will go to their graves believing that this false description of what they are made of is correct. And so, this lie to children becomes a lie to adults. What's more, this lie is completely unnecessary, because all the false ideas presented in the early grades could easily be corrected before students have the option to give up physics in grade 9 or 10. And there are many videos on YouTube which show that it is not difficult to introduce lay people to the really important stuff we are not taught in school. Please note that I'm saying introduce and not teach. A good example is Brian Greene's Fabric of the Cosmos Quantum Leap. In less than an hour, he introduces the mysteries of quantum mechanics in a way that high school students can understand. I used extracts from this documentary in episode 11 to describe how quantum mechanics is both highly successful and not understood. This gives a good balance of what we do know and what we don't know. The truth is a combination of both.
In spite of all its triumphs, quantum mechanics remains deeply mysterious. It makes all this stuff run, but we still haven't answered basic questions raised by Albert Einstein all the way back in the 1920s and 30s.
Quantum mechanics is the most successful theory that we physicists have ever discovered. And yet we're still arguing about what it means, what it tells us about the nature of reality.
This balanced view is missing from our education. Instead, the unsolved mysteries are completely avoided by teaching us a hopelessly outdated and flawed version of what we are made of. To understand how misleading this lie to children is, let's take a look at the many worlds interpretation of quantum mechanics, which I introduced in episode 11. This interpretation proposes that the universe is continually splitting into multiple parallel universes, which would mean that there are many versions of you out there that you don't know about. Sean Carroll is one of the most vocal supporters of many worlds. Let's listen to Professor Carroll.
It's happening all the time. There are radioactive decays in your body roughly 5,000 times a second, and every one of those duplicates the universe, okay? It's not a duplication of the world with twice as much energy and everything. There's a certain amount of worldness in the equations, and it's being subdivided and differentiated as time goes on. Think of the world as splitting, not as being copied in some way.
Though that may sound utterly bizarre, it's not a fringe interpretation. Many worlds is considered a mainstream interpretation of quantum mechanics due to the amount of support that it has in the physics community. Sean Carroll, Max Tegmark, and David Deutsch are all prominent award-winning physicists who have written books which extol the virtues of the many worlds interpretation. The Amazon reviews and ratings reflect the support that they have. This approval is also reflected in the thousands of supportive comments that accompany videos about many worlds. To the layperson, this idea of splitting universes probably seems ridiculously impossible. That's because there is a huge gap between the public worldview, which is based on the flawed planetary model, and physicists' worldview, which is based on the quantum model. The quantum model must clearly enable the splitting process, otherwise no physicist would even consider many worlds. It's hard to convey how shocking this is when you first encounter it. According to Sean Carroll's example, there are beta decays in your body that cause the universe to split, such as the decay from potassium-40 to calcium. After each split, a new parallel universe comes into existence, and there are now two versions of you occupying the same space, one in universe A and the other in universe B. Version B of yourself might then decide to move across the room, moving through version A, and then perhaps moving through a friend who happens to be in your path in universe A. This mainstream theory highlights our true nature according to quantum physics, which is that we are as etheric as ghosts. The fact that we feel solid is an illusion. As I explained in episode 3, when we clap our hands together, the outermost electrons in our skin are what comes together first. Electrons have a negative charge, and like charges repel, like tiny magnets. This creates the illusion that we are made from solid particles, whereas there is nothing solid in an atom. Particles of matter are not tiny solid balls as depicted in the outdated planetary model. So then, what is a particle according to the quantum model? That's a complicated topic, and we need to find a simplified answer for schoolgoers. This is not a simplified answer, as is claimed. This is a wrong answer that completely misleads us about the nature of physical matter, which is fundamentally etheric, not solid. In my opinion, the best way to introduce quantum particles to students is to use this picture of an electron.
Swedish researchers have released the first clear video ever taken of an electron riding on a light wave. Scientists used a device called a quantum stroboscope to freeze the electron's motion at different stages, just as you would freeze a hummingbird's wings in flight using a regular stroboscope.
According to modern physics, a particle is an excitation or vibration of a quantum field. I covered quantum fields in episode 3. If we look at the shape of this microscopic vibration, we see how well it matches the vibration of sound in water. This is a slow-motion video of a dish of water resting on a loudspeaker that is vibrating at a specific frequency. Since vibrations are standing waves, this example demonstrates how an electron can be both wave-like and particle-like, since it is roughly spherical like a particle. But what is vibrating in the case of an electron? Is it something similar to water? Yes, to some extent it is. According to David Tong, who specializes in quantum field theory, a quantum field is a fluid-like substance that occupies all of space.
So there is spread everywhere throughout this room something that we call the electron field. Okay, it's like a fluid that fills this room and in fact fills the entire universe. And the ripples of this electron fluid, the ripples of the waves of this fluid, get tied into little bundles of energy by the rules of quantum mechanics, and those bundles of energy are what we call the particle, the electron.
So Professor Tong is basically saying that particles are little bundles of energy, which are waves or vibrations of an invisible fluid-like substance which we usually call empty space, but is clearly not empty space. Please note that his use of the word substance here is not mainstream, but I do believe it is the most helpful word when talking to a lay audience. A good way to undo the false conditioning that we are made from tiny solid balls is to imagine that the invisible substance around us is a really thick fluid. Moving through it would take a lot of effort if we were made from tiny solid balls. Then, as you walk around, remind yourself that the reason you are passing effortlessly through this thick fluid is because we are vibrations of the fluid, traveling through it as easily as sound waves transmitting through water. This invisible substance we're all made of is a kind of quantum ether. So I believe that describing physical matter as etheric is appropriate and would be very helpful in conveying the correct general impression to the public. Now we can see why quantum theory allows physicists to speculate that parallel universes could coexist in the same space. Because if everything is made of vibrational waves, then we can see from this picture that waves can pass through each other without affecting each other. In this video, Matt O'Dowd uses the same analogy of ripples on a pond to explain how many worlds can overlap without interfering with each other.
We can think of the different worlds as separate patterns of ripples on the surface of the pond. They overlap in location, but are so hopelessly out of phase that they can never interfere with each other. They just pass straight through.
What Professor O'Dowd is saying, very briefly, is that the waves that make up Universe B could become out of phase with the waves of Universe A as a result of interactions with the general environment. That's what would put the two universes out of touch with each other. So now we can see that once it became known that our basic nature is etheric and vibrational, it also became easy to propose parallel realities such as many worlds, or the so-called spirit realm, using variations of the same theory. In other words, the spirit could be a being that is able to fade in and out of our reality due to changes in phase, or more likely, due to changes in vibrational frequency. So a spirit or ghost could be just as physical as we are in its own frequency range, and could perceive us as being etheric. This explains the concept of other dimensional realities and other dimensional beings, although other frequential would be more accurate. The other frequential nature of a ghost would make it look like a hologram to us and vice versa. Now that we understand the etheric nature of ourselves, we can see why it's feasible for physicists to propose that the universe is a kind of hologram.
Surprising new clues are emerging that everything, you and I and even space itself, may actually be a kind of hologram.
It's hard to convey how surreal this is. The general public is being misled about the basic nature of ourselves and the universe we live in. Meanwhile, the scientific community is locked in a battle against scientific misinformation and mistrust of science. We are also misled into thinking that physicists have figured out how the universe works. Meanwhile, as Max Tegmark said, physicists are still arguing about what quantum mechanics means. In other words, arguing about how to explain the seemingly impossible behavior of particles, and arguing about whether any of these different interpretations is correct, such as many worlds. This argument has resulted in the most embarrassing graph in modern physics, according to one physicist. And that will form the basis of my next video, which will be all about chaos, rebellion, and desperation in modern physics.